Welcome to Spring LIB.
Our question says that we have a distance to a star that is about 4 light years away. So L, the distance to the star, is 4 light years. The planet is orbiting the star at a distance equal to that of the Earth-Sun distance. So I called that distance S, and it's equal to 1.5 times 10 to the 11 meters for the Earth-Sun distance. It wants to know what the minimum diameter would be on Earth-based telescope aperture to obtain an image that resolves this star-planet system. So we're going to assume the light that it's emitted by the star that we're looking at through our telescope has a wavelength lambda of 550 nanometers, or 550 times 10 to the minus 9 meters. So the limiting angle of resolution for a circular aperture is given by theta, the angle, is equal to 1.22 times the wavelength that we're looking at, lambda, divided by the diameter of the lens. We'll call that d. So we're going to be trying to find d here, okay? So first thing we can do is convert the distance of the distance between Earth and the star system into meters, because right now it's in light years. So L here is going to be equal to 4 light years times the conversion between 1 light year and a meter here. So a light year, of course, is how far light can travel in 1 year, traveling at 2.99 times 10 to the 8 meters per second. So that distance ends up being 9.46 times 10 to the 15. And the units here would be meters, right? So that's how far it can travel in 1 year. If you know how far it travels in 1 second, you just multiply it by the amount of seconds in a year. So that's how many meters it can travel in 1 light year. So carrying out this operation, we find that this distance is equal to 37.84 times 10 to the 15 meters. So now we have the distance to the star system in units of meters, so it matches our other units. And the distance between the star and its orbiting planet, again, is S, right? Here, the planet orbits the star, so the distance traveled by the planet is going to be, we'll start a new page for this, S is going to be equal to L times the angle of resolution here, theta. Or in other words, theta is equal to S over L. So now we have 2 equations for theta. So we can set those 2 equations equal to one another. So we have S over L, where we know both of those terms, is equal to 1.22 lambda over d, since both of those are equal to theta. Oh, I said theta and I started drawing it. It should be lambda divided by the diameter d. So we can just rearrange this equation to solve for d. We find that d here is equal to 1.22 lambda times L over S. So if we plug all these values into this expression, we find that the distance d here is equal to 1,694 times 10 to the minus 4 meters, or 16.9 centimeters. So I'll just write it in units of centimeters. So this comes out to equal 16.9 centimeters. And we can go ahead and box that in as our solution to the question.